Thank you. Okay, thank you everyone for coming in today. My name is Marco, this is Gianmarco, and we are both core developers in the Namada team. So today we're gonna have this workshop. We're gonna first introduce the team. After that, we're gonna try to guide you through the Namada application. So first, we're gonna teach you how to actually download the binaries and run the full node on your machine so that you are able to basically sync to a running blockchain. And the second part of it would be about the wallet so that you will learn how to actually interact with the wallet and generate your secret keys, addresses, make some transfers. We're going to see shielded transfers, how governance works, and so on and so forth. Okay, first of all, what is Namada? So Namada is a layer 1 blockchain. We are really focused on privacy at the moment. It's a proof of stake blockchain. We are based on Tendermint BFT as our consensus engine. We are also very focused on multi-asset private transfers for both our native token and also non-native tokens. Also, Namada provides a public good funding mechanism, which is based on our governance mechanism. This is so that the Namada protocol and the Namada environment can basically incentivize developers to produce good, healthy application that every Namada user can benefit from. Why should you choose Namada? So Namada offers trustless bridges that basically retrofit privacy to the world's most popular assets. We are IBC compatible. We also have an Ethereum bridge. As I was saying earlier, we are really focused on privacy. That's why we provide a shielded pool, actually a multi-asset shielded pool for all of your private transfers. And the PGF mechanism is able to guarantee that contributors can give back to the community of Namada. This is just a real nice picture of the team. Half of these guys are actually working on Anoma, which is the complete protocol that you're going to see probably next year. For this year, we are really focused on launching Namada, which is a subset of Anoma. Okay, we can start with the real workshop now. The workshop is meant to be interactive, so we're going to go through some CLI commands. So we are also providing the slides for you so that it might be easier for you to just copy-paste the commands and you can see the results on your machine. In case, you should just be able to type them by looking at this presentation in here, just fine. Okay, first things first, we need the binaries, of course. So there's multiple ways you can get your binaries. The suggested way is always to compile the binaries from the code. Unfortunately, it takes a bit of time, so for the sake of this workshop, we're going to provide you with some pre-built binaries that you can download from these links with these commands. Might be a little bit more complicated. You want to type? Maybe it's better. Yeah, thank you. Oh, just mind that if you are running on a ARM Macintosh, so M1, M2, the link is exactly the second one, just change Darwin x8664 with ARM in capital letters. There was a late update. We're sorry for that. Okay, we can continue. Now we need to extract the tarball with this command. And we also need to make sure that we give executable privileges to the file. And also to ease the tasks of this workshop, we want to make sure that we move or copy, as in this case, our executables to somewhere in path so that you don't need to specify every time the complete path of the executables. Okay, nice. As Gian already showed you, one thing you want to make sure every time you install Namada, especially if you'd like to join one of our live testnets, is to make sure that the version you're running is the intended one. For that, there is this simple namada -- version command. In this case, we are aiming for v15.4, which is exactly what we get. Okay, as I was saying before, we rely on Tendermint BFT as the consensus engine, so we also need the binaries for our consensus engine. Again, we need to curl the binaries from the given URLs. And extract them. As previously, just move them to path so it's easier to use. Just let us know in case anything is unclear or you need some help. We are really happy to help you in case. Or if we're going too fast for you, you want us to slow down a bit. Okay. Next, we check the Tendermint version, which is 1.4 ABCI plus, which is great. So, you now have the binaries, so you're technically ready to launch the application. But first, we want to join a running network. For that, you always need a chain ID. For our live testnets, we usually provide the chain ID 1 day earlier. In this case, we're running a DevNet for the sake of this workshop. So we're providing you with this chain ID to join the testnet for this workshop. Okay. At this point, the only command left is actually to run your ledger. For that, the command is so simple, namada node ledger run. Now, it will take some time to catch up because we launched the DevNet a few hours back. So you will see a lot of logs in your terminal. That's fine. It's just catching up the blocks with the peers, that in your case should be only one. Meanwhile, we can probably have a look at the config slide. So, for a correct working, Namada stores some configuration files in some predefined location. For Linux is on .local share Namada, while for macOS is in library application support Namada. In here, you can find some folders and some files. Okay. So we can have a look at the global config toml first, really quick. This is just basically the chain ID that we joined before. This is where we store the desired chain ID. We then have an internal DevNet folder. This is actually a name which is because of the DevNet. It will change for testnets and it will change for mainnet. In here you can see that there's the DB folder, a Tendermint folder. We have a couple of folders for our cache for the WASM executables, both transactions and validity predicates. We have our wallet toml file. We have the WASM folder containing the compiled WASM executables. So we are now looking at the wallet toml, for example. You see we have different sections. At the moment, it is populated with the known addresses. Some of these come defaults with every DevNet and testnets. We're going to create a few more later on during this workshop. And then we can also have some keys or payment addresses or pending keys these are all related to MASP. At the moment, they are empty, but we will populate this as well. Okay, this is actually our configuration file, the Genesis file for Namada. As you can see, we have a first section in which you have some really general configurations like the Genesis time at which the ledger should be launched. The native token for the ledger, for us, is always NAM. Faucet pool difficulty for testnets and devnets. We also have a faucet from which you can withdraw some tokens so that you are able to experiment it with the chain yourself. To prevent DOS, we require a proof of work, and we are able to set the difficulty of this proof of work every time, depending on how we feel about it. We have then a section about the known validators, so the Genesis validators. You can see their public keys for consensus, so Tendermint, DKG public keys, the address actually on-chain, the amount of tokens they have, the amount of non-staked tokens that have, the commission rate, and which validity predicate is that validator running. At the moment, they all run a default BP validator, but they will be able to provide their own validity predicate in the future. We then have also a section about the tokens. Just here, so we define the tokens that we recognize in our chain, and then we get to the parameters section. In here, we have a few protocol parameters. These are controllable through the governance mechanism and allows us to modify the behavior of the chain without the need for an hard fork, basically. So you see some parameters can be the maximum amount of bytes for a governance proposal, the maximum expected time that we should take to produce a new block. We have 2 whitelists at the moment, so we don't at the moment accept any transactions. The transactions must be whitelisted, and the same holds for the VPs. We also have some default VPs and the amount of fees that you have to pay to submit your transaction. After that, we have some more parameters which are more specific for some of the parts of the ledger. For example, we have our proof of stake parameters and the governance parameters as well. I think that's pretty much it for the Genesis file. So the node catched up, and in here you basically can see the state that you can expect when you run your ledger and you are up to date with the last block. So the ledger will print out some information for you. Usually you're interested in seeing the committed block. It will provide you with the hash, the height of that block, and it will also show you some information about the transactions in that block. More specifically, at the moment, as you can see, we had applied 0 transactions, of which 0 were wrappers. Of course, none was successful. We rejected none, and there were no error. We are also updated on the cache size and the TX cache size. We might remove these in the future. At the moment, they are very useful for debug purposes. Yeah, I'm gonna pass it down to Gian, who is gonna explain you probably the most interesting part, which is how to interact with the wallet, generate your addresses, and make some transfers. Change of program. I'm speaking again. Sorry about that. Okay. We can have a look at the wallet now. So as we've seen before, your wallet is currently populated only with some default addresses. But of course, we want to make this thing a little bit more interactive for you. So the first thing that we want to do is to generate an implicit address. An implicit address is basically an address which is only known to you. It's not known to the ledger for the moment. So the command for that is simply Namada wallet address gen -- alias, and then you're free to select the alias that you prefer. This makes it really easy in the future for you to operate with the wallet without the need to remembering the exact address. It will always prompt you for a password because we store all of this data encrypted. There is technically an option to store it unencrypted. We strongly suggest against that. So always make sure to encrypt your addresses and your keys. The most recent block, John? Okay. Now that we have an implicit address, we would like to establish our address. So create an established account. An established account, contrary to an implicit one, is known to the chain. It's produced with a transaction that gets included into a block, and we require some WASM code to be executed. This will write some key values in the storage of Namada so that everyone is aware of this new established account. You always require an implicit account to generate an established one. And we will provide you, since now you are going to have an account on chain, we will provide you with a default validity predicate so that you are able to validate the transaction coming into your account, or better, involving your account. As you can see, meanwhile, we can have a look at the logs. This is the client-side log. So when you submit a transaction, you actually also following the execution path of it. And we, in this moment, we actually have a two-step execution process. So we first accept your transaction, and we make sure that you are paying the fees for that. And in a second step, we actually execute the transaction itself. So you can see that it takes a bit of time. This is because we basically need 2 blocks to commit your transaction. Okay, now that we've done that, we can check that it actually worked by asking our wallet to list all of the known addresses. And we can see the my account address, which is actually an established one, and the my address, which is just below, and it's the implicit one that we created in the first place. Okay, this is a really quick summary about what I've just told you, basically. So the difference between implicit and established account. Just remember that to create an established account, you always need an implicit one before, and that the established account being present on-chain requires a validity predicate, for which we provide a default for you so that it's easy to start working with Namada. Okay. If we want to operate on the chain, as I was saying before, we need to pay fees. So we need some tokens. Being this one testnet, we have a faucet account from which we can withdraw some token. We have a limit all the times. At the moment, the limit is set to 1,000 nums, so you cannot withdraw more than that, but you can also always submit more than one transaction and require more tokens. The command is quite long this time, but it's nothing crazy. Just remember that the source is the faucet, and the target is the account from which you want to actually give these tokens. Is everything clear up to this point? Anything shady, unclear? You want to revise anything? Okay, cool. So we can now check the updated balance of our account. And we can see that the balance for NAM is 1,000. You always need to specify the token for which you want to check the balance. Otherwise, it's going to print out the balances for all the tokens that you own. As I was saying before, we support multiple assets. So it's always a good thing to filter out the information you're really interested in. Okay, so basically, we now have an established account with a few tokens. So we can start submitting some transactions with it. Okay, the first thing that we can do is trying to stake some of these tokens to one of the known validators. You can technically also try to become a validator, but that's a really longer process that we're not willing to show you today. So for now, we'll just stick to staking some tokens to a known validators. To do so, we first need to see which validators are available on the chain, since we just joined it and we know nothing about it. So with the command Namada client bonded stake, you can basically have an overview of what's happening on the proof of stake side of the chain. We see that we have 3 different validators and the total bonded stake of each one of them, and then the total bonded stake of the entire chain. So we can, for the moment, just choose a random one among these. We really don't have any preferences. And the command for bonding is simply Namada client bond, the source from which you want to bond, and the target validator for that, plus the amount you're willing to bond. We need to withdraw, I guess, once more. Cool. So we can just go. Okay, we can go to the next slide. And then we can query the delegation to check that it actually worked. Okay, as you can see, the total bonds is 1,001, which is correct, but you also need to be careful about the remaining active bonds from epoch 36. This is because your bond is not immediately available. There is a gap between when you submit the transaction and when the bond becomes actually real. But we can see that at epoch 36, we actually, in 36 epochs, we will actually have our 1,001 tokens bonded to the validator that we chose. The same goes in case you wanted to go the other way and unbond some tokens from the validator. You have to wait for a few epochs. This is because of the slashing mechanism in place. We cannot release funds immediately. We have to do some validity checks. Okay, now to the fun part. We'd like to transfer some NAM. We, in theory, have an address to let them transfer some NAMs. Or it would be even better if you could exchange some NAMs between some of you, exchanging the addresses with each other and trying out this command. Whatever. Otherwise, we can provide you with a fixed address and you can try sending the tokens to us. I think so, yeah. Is everyone of you in the Telegram group? We're going to share the address in there. Yes, no, maybe. I don't know. Can you repeat the question? Okay, hope every one of you is here. Otherwise, John, maybe you can leave. Can we create a new slide? Has any one of you opened the slides locally? Are you? Because that's another way we can share with you the address. We can create quickly a new slide and copy paste the address in there. So that if you're not on the Telegram group, you can get the address from here. I would avoid actually typing the address out yourself because it will take forever, I guess. Now they can basically submit a transfer to us so that we can show them, we can show you how to perform a transfer on Namada, and we're going to check the balance afterwards just to make sure that they actually work. Also, yeah, that's also an option. We're going to send some tokens between the two addresses that we created while you try to submit the transfer to the one that we provided to you. Just remember, of course, that you have a fixed amount of NAMs, depending on how many times you requested tokens from the faucet. You can also try to transfer more tokens than you actually have, just to see the result of the transaction we rejected, just in case. Or transfer a token which is not a NAM, for which you don't have a balance at all. Okay. Okay, just one note on this. As you can see, we get in the logs, transaction is valid twice. But this is because of the two blocks execution mechanism that we have in place. So the first time you see, the first time you read transaction is valid, that actually only means that we accepted your transaction in a block, and we are going to execute it in the next block. In the following block, if the transaction is valid, you will see the second log just after info. So make sure to wait for the second log, because the first one just means that you have paid the fees and the transaction is in a block, but that doesn't say anything about the transaction being valid. Okay, so as we can see, the transaction was actually valid in this case, so we can try to query our balance on either side for us. Okay, and we can see that the balance is indeed updated. Is anyone trying to transfer some tokens in here? You need some help, maybe? We're fine to go? Can we continue? Yes. Okay. So we've just done a transfer. We can go to the next slide, maybe. But what we've done is a transparent transfer. So everyone can see nothing is private at the moment. So what we want to do next is actually start to operate on MASP. MASP stands for Multi-Asset Shielded Pool, and it's kind of like a Zcash pool, but we support multiple assets. So the first thing that you need to do if you want to operate privately on the MASP is to actually generate a key. Contrary to Namada, which is account-based, MASP is UTXO-based. So we need new addresses to operate on this. The first command that you need is the gen key, and you have to specify another alias, again, just like for the Namada account, for convenience. And after that, as always, we want to make sure that the command indeed works. As you can see, we have our new alias in the wallet, so we can proceed. Now, you have generated a spending key. Now, we also need a way to receive some tokens in the shielded pool, and for that, we need to generate a payment address. For that, the command is wallet masp gen address, and you also need to submit to provide the key that we have just created. again, we double check that the transaction was actually valid. Oh, without that. Okay. Okay, now you have your spending key and your payment address on MASP, but of course you have no balance in there because everything you have is on your transparent balance. So the first thing you want to do is to shield some tokens, which simply means transfer some of the tokens you own on one of your transparent balances and move it into one of the accounts, let's say, not really an account, but move it into the MASP using your payment address. Multi-asset shielded pool. I think we're going to start maybe with some assets at Genesis, and then we can probably support more through the governance mechanism. But we're going to have multiples already from Genesis. Okay, with the client's balance command now, you can also check the balance of your spending key on the MASP. And indeed, it matches. Okay. Of course, shielding is not the only operation that you can do. You can also perform a fully shielded transfer in which you transfer some tokens inside the MASP from one spending key to a payment address. And also there's the opposite of the shielding process, which is the unshielding one, from which you withdraw some of your tokens outside of the MASP. For the sake of this workshop, we are skipping over those commands, but you can find more in the documentation. Once you have seen the shielded command, the other two are pretty much more of the same. Next is our governance mechanism. So the purpose of governance is to basically reach a common agreement over certain questions. This is in place so that we can allow the flexibility of the chain without the need for an hard fork every time. To work with governance, there are basically two actions. The first action is, of course, to submit a proposal so that the rest of the stakeholders in Namada can have a look at it, study it, discuss probably, see what it does. Very important, also because governance proposal in Namada allow for an arbitrary payload that can be executed by the WASM virtual machine. So we allow code execution through the governance mechanism. That's why you always want to check the governance proposal. You should never vote yay for something that you do not understand. You should always make sure that you fully understand the proposal before approving it. The second step is, of course, to vote on a proposal. Vote is not available to anyone. You have to have some staked balance to vote on a governance proposal so that we can make sure that voters are actually stakeholders of Namada. We don't allow random people to come in and vote on something that will affect the entire community. Okay, so For this workshop, we actually already submitted 2 governance proposals. We leave the task of understanding how submitting a governance proposal works to another time. It requires the preparation of a JSON file describing the purpose of the proposal and some other data. So for now, we are going to only focus on voting on a proposal. Of course, the first thing is to see which proposals are around. For that, we have a command, which is client query-proposal, that, as you can see, will logs out the current active proposals. At the moment, we have 2. We have proposal 0 and proposal 1. You will see the type. It's default. We support different types of governance proposals. The one you are more interested in are defaults. We're going to have some other proposal types for our PGF mechanism and for the Ethereum bridge, which will subject to different rules. But for the general usage of the governance mechanism, the default proposal is the one to go with. You will also see the address of the author and then some epochs. So when you submit a proposal, there is a voting window. So we are providing you with the start epoch when you can start voting on the proposal and the end epoch by which you have to submit your vote if you want it to be counted. Mind that we do not accept votes past the end epoch, and at the same time, the proposal is not necessarily applied exactly at the end of the epoch. We actually have a grace epoch between the tally mechanism and the execution of the proposal itself, which lasts for at least 3 epochs, can be more, just so that everyone can actually prepare for the proposal application. In this case, it's double since we have 2 proposals around. Okay. You can also pass an optional proposal ID to the query proposal command. In this case, you will be prompted with more detailed information about this specific proposal. In this case, you can see the content, which is basically the JSON I was talking about before, in which we have different fields. Requires is just a field to basically specify that this specific proposal is based on another one. In this case, it's based on proposal 420 that we don't have just for the sake of the workshop, but you have a way to make clear to the others that this proposal is meant to be applied after a certain other proposal. There are some details. This is just some text to explain what you want to do with this proposal. A created timestamp, the motivation, very important, a title, again, the authors, and also a license. This is, again, very important for what I was saying you before. So you can basically attach some arbitrary WASM code to your proposal, which is just code. So basically, we want to make sure that you have the chance to specify the license that you would like to apply to your code. After that, again, the epochs, and at the moment, you can also see the amount of yay and nay votes that we've received. There's none at the moment, and the status is ongoing. So we are still good to vote it. To vote, the command is Namada client vote proposal. You need to specify the proposal ID and the vote. Cannot vote yet. I'd also like to mention that there is the concept of a delegate in Namada. So you can choose a delegate for the governance mechanism. If you find that someone is really into the governance mechanism and you trust them and you basically feel yourself very aligned with them, you can set this guy as your delegate. That means that if you do not vote, his vote will actually count for your staking amount as well. In this case, you're always able to override the choice. So if you, for once, don't feel like the same as your delegate, you are free to vote opposite to him, no problem. You're also able to change your delegate if you don't like him anymore. Can we check the yay votes on the proposal? Yes? Withdraw the proposal once it has been submitted to the chain? No. So, withdraw a proposal, say that you change your mind, you don't want the proposal to be applied anymore. At the moment, we don't have such a feature. So once the proposal is out, people can vote on it. Sorry? You can override the vote. So say that you vote yay, you think twice, you want to vote nay, you can submit the vote again if you are in time. You must be sure that it's still, we haven't reached the end epoch yet. You can submit as many votes as you want. We are going to always override the same vote. Of course, you're going to pay for fees for that, so this maybe do not exaggerate. Proposal 1 or 2 or 0? No, it's 0. Still not active, probably. Yeah, okay. Yeah. It depends. At the moment, how long is an epoch for this DevNet? John, Mike.
So I thought I set it to 5, but maybe I set it to 10. So it's a governance parameter. We can check it. We can change it at runtime, basically, but it's something that's set at Genesis. So yeah, it should be. I think it's 10 instead of 5. Yeah, but we think for mainnet it will be 1 day.
Okay, so basically that's a wrap for this workshop. So we've seen, first of all, what Namada is, the protocol, the blockchain, layer 1, BFT consensus, the main focus on the chain, and why you should choose Namada. And then we basically saw how to run a full node on your local machine, how to sync it with the running chain, and how to submit commands from the client by making RPC calls to your local node, which is running. We saw, again, installing and running a full node. We saw how to read the ledger logs, in particular, how to see how many transactions have been accepted, applied, how many have failed in that specific block, and the height. We've seen how to create and list both keys and addresses, transparent, and also payment addresses and spending keys for the MASP. We've seen how to perform both transparent and shielded transactions. More specifically, we have seen how to perform a shielding operation, but the other two are basically the same. We have seen how to bond some tokens to a validator. and we also saw how to vote on a governance proposal. So basically what's left is just how to submit a proposal of your own and the two other MASP operations that we haven't covered in here. This is pretty much it as a quick guide on how to operate on Namada. You can see more at the docs. We are making sure that our docs are up to date and well maintained. If anything was unclear, it's pretty much, there's pretty much a good explanation on the docs. And you can also find us on Twitter, Discord, on our website, and you can check out our repo on GitHub. So that's a wrap. Thank you very much for coming today, and yeah, see you around. Any questions before we leave? Anything unclear? Awesome.